These are the practice problems for lesson 13, more solutions to linear equations. And in problem number 1, you are given 5 equations, and you're asked to solve each of these equations with x equal to -3. And then also you're asked to solve each of these equations with y equals 2. Now, if you look at each of these equations, notice that they're all in the slope-intercept form. So the slope is 6 2/3. This is the slope of -1 for this equation, 3/4, and 1 5/10. That's also 3/2. 1 5/10 is the same as 3/2. The y-intercept for each of these, this is a +8. This is 0. This is a proportional relationship that goes through the origin. So this is like takes the form y equals kx, and k is the constant of proportionality from 7th grade, or it's the slope. The y-intercept is +5. The y-intercept is a -2.5. Notice that this is subtracting a +2.5. And then if you use the inverse operation of addition, then you're going to use the additive inverse of a -2.5. So this y-intercept is a -2.5. And the last one, the y-intercept is 11. So we're going to use that information. We're going to solve the equations like we're supposed to, and then we're going to use this additional information to graph each one of these, because the points that you come up with in the end are solutions to the equation, and they are points on the line that is a graph of this equation. And this is equation A right here. Y equals 6x plus 8. Y equals 6x plus 8. Use x as -3 and y as 2. So I'm just going to work through it on the left side for solving for y. And this is not too bad. -3 times 6 is -18. -18 plus 8 is a -10. And so this side, y is equal to -10. So this point, the x-coordinate is -3, the y-coordinate is -10, solves this equation, is a solution for this equation. On the right side, y is equal to 2 and x and equals 6x plus 8. This is a little bit tougher because you have to do some algebra to get this x by itself to figure out what x equals. Well, the first thing I did is I moved this entire expression on the right side to the left and the expression on the left side to the right. It's just easier for me to work with what I'm trying to solve for on the left side. And then I'm going to move this 8 back over to the right side by adding the additive inverse. So I'm going to add a -8, that makes this 0, and add -8 to the right side. So now I have 6x equals 2 plus -8. Well, 2 plus -8 is equal to -6. Now to get rid of the 6, I have 6 of these things, but I only want one of them. So I'm going to divide by 6, or I'm going to multiply by the multiplicative inverse, which is 1/6. So 1/6 times 6 makes this 1, and -6 times 1/6 is this product right here, -6 over 6. Well, that simplifies to -1. These 6's cancel out, and you're left with a -1. The opposite of 6 divided by 6, or the opposite of 1, is -1. So this point, x is -1, y is 2. So now you have 2 points that are on the line, which is a graph of this equation. So I gave this to you. You can print this off and use this as a blank graph to graph this equation on your own. And so the first thing is to place the points that we got from solving the equations. So those 2 points were -3, so we solved it with x equal to -3. So that was -3, -10, so this point. And then -1, 2. We solved it with y is equal to 2. We got x equals -1. So this is -1, 2. Both of these points are on the graph of this equation, and both of these points are solutions to this equation, make this equation true. Now, what else is true is that the y-intercept makes this equation true, and that y-intercept is a +8, so 0, 8. So another point on this line is right here, a +8, And then we can use the slope to check to make sure we've done everything correctly. The slope is 6. That means for every unit along the x-axis in the positive direction, you're going to go up 6 units along the y-axis in the positive direction. So it's going to be 1 over, that's a positive 1, and up 6. That is the change in y. How many units is y changing? It's changing 6 units. Over the change in x. How many units is x changing? It's changing 1 unit. For every 1 unit, you go up 6. So this is 1, 6. Now you could also go in the negative direction. A -1, -6. That's also a slope of a positive 6, because a -6 over a -1 is positive 6. So -1, -6, -1, -6, -1, -6, or +1, +6, +1, +6, and +1, +6. So everything checks out. So this is a graph of this equation, and these 3 points are solutions to this equation. This is the slope, and this is the y-intercept. This is equation B. Before we look at this one, I want to go back to the beginning just for a second and show you that if you have x equals -3, this is also an equation. This says x equals -3, y can be anything. So what does a graph of x equals -3 look like? We'll look at that at the end of this problem, and also y equals 2. So in this case, x can be anything. So you move along the x-axis, but y always has to be 2. So what is a graph of y equals 2? What does that graph look like? All right, so back to equation B. So we're going to use x as -3 and y as 2. So working down the left side, so this is the equation that's a proportional relationship. So this goes through 0, 0. So when x is 0, y is 0, and when y is 0, x is 0. All right, so 2/3 times -3. So these 3's can factor out -1 times 3. These 3's cancel, and you're left with -1 times 2. Well, what's the opposite of a positive 2 is a -2. Up here, the opposite of a positive 3 is -3. So this is the opposite of a positive 3 is -3. So you can pull that -1 out as a factor, and that way I can easily see that I can cancel these 3's. 3 divided by 3 is 1. So you're left with the opposite of 2. So when x is -3, y is -2, that is a point, once again, on the line. That's a graph of this equation. It's also, this point is also a solution to this equation. What about when y is 2? This is a little bit tougher. Now this is going back to 7th grade when we wanted to go the opposite way in solving proportional relationships. So in this case, we're given y, and we want to figure out what x equals. So you're going to multiply by the reciprocal of the constant of proportionality. That is 3/2. So 3/2 times 2/3 is 1. That makes this a 1 on this side. And so 3/2 times 2, these 2's cancel out. 2 divided by 2 is 1, and you're left with 3. So x equals 3. And that makes sense. 2/3 of 3 is 2. Makes sense. So this point, 3 for the x-coordinate, 2 for the y-coordinate, is on the graph of this line, and it is a solution to this equation. So I gave this to you as a blank sheet in the PDF that's attached to this video, so you can do this on your own. So I would graph the 2 points first. This is -3, -2, so we solved it with x equals -3, and we solved it with y equals 2. This is the origin right here, and this is also a point on the line. So what we know from this equation is that the slope is 2/3, and the y-intercept is 0. Well, with the slope of 2/3, you can go over 3 units. This is 3 units in the positive direction, 2 units along the x-axis, and 2 units along the y-axis in the positive direction. So +3, +2. That's what the slope of 2/3 means. Is how much is the y value changing? So it's changing 2 units. As you go from this point to this point, It's going up 2 units, and how much is the x value changing? Well, that's changing 3 units. As you go from this point to this point, you're going along the x-axis 3 units. So this is the change in y, which is 2, over the change in x, which is 3. So the slope is 2/3. And you could also go in the negative direction. That is a negative 3, 1, 2, 3, negative 2, 1, 2. That's also a positive slope of 2/3. So everything checks. Slope is 2/3. Y-intercept is 0. This is a proportional relationship. This is equation C. Y equals a negative x plus 5. Now remember that this negative x means that the value, it's called the coefficient, the number that's right next to this x is actually a -1. So that's going to be useful a bit later. So replace x with -3 and replace y with 2. So now notice you have to be careful. X is replaced with -3. So this is going to be the opposite of the opposite of 3. So the opposite of 3 is -3, and what's the opposite of a -3? That is a +3. So that's why this is +3 down here. So once again, this is the opposite of a -3. What's the opposite of -3? It's a +3. So y is equal to 3 plus 5. Y is equal to 8. So when x coordinate is -3, the y coordinate is 8. So once again, this is a point that's on the graph of this equation. This point is also a solution to this equation. The coordinates are a solution to this equation. So when y is 2, a little bit tougher to think about. I have a negative x here. Well, if I add the additive inverse of a negative x is a positive x. A little bit hard to think about if you're not used to that. So a negative x plus a positive x, that makes this 0. So I have to add that positive x to the left side. So now I have x plus 2 equals 5. And x is equal to 5 plus a -2, because I'm going to move this 2 over to the right side. So I'm going to add a -2, that's the additive inverse, add a -2 to the right side. So now you have 5 plus -2, well, 5 plus -2 equals 3. So x equals 3. So when y is 2, x equals 3. So now I gave you once again the graph, a blank graph, so you could practice graphing. The equation, I would place the 2 points that we just figured out. So this is 3, 2. When y is 2, when x is -3, we calculated that y is equal to 8. So this is a -3 here, +8. So what else do we know? Well, we know that the slope is -1, and we know that the y-intercept is 5. So here's the y-intercept right here. So this point is on the line. This is 0, 5, and we know that that slope is -1. Well, if we go a -3 units in the x direction and a +3 units in the y direction, this is a +3. That's the change along the y-axis, 3 units. Change along the x-axis is -3. So +3 over -3. Remember, it's the change in y over the change in x. So +3 over -3, and that is equal to -1. So that matches. Here's the slope, -1 here. We're actually using that slope to check this point. Y-intercept is 5, so everything checks. Slope is -1, y-intercept's 5, so all's good. This is equation D. Y equals 3/4 x minus 2.5. Now this one looks kind of tough. It has fractions in it and kind of difficult to deal with at times. One of the things to look for is where you can factor numbers out. You can write numbers as factors and cancel the common factors in the numerator and the denominator, because that equals 1. So we're going to look for that as we work through this. First of all, when x is -3 and when y is 2. So working down the left side, a -3 times 3/4 is a -9/4. 3 times 3 is 9, and it's the opposite of that. So it's a -9/4 plus. So I'm going to change the operation to addition, and I'm going to add the additive inverse of of a positive 2.5, that's a negative 2, and I'm going to change the half to 2/4 because I have fourths over here. I want fourths over here. So a little bit tough. You have to remember common denominators, things like that. So if a negative 9/4 is the same as a negative 2 1/4. 2 times 4 is 8. That's going to be 8/4. Plus you have one more fourth. So that's 2 1/4, but it's the opposite of that, or a negative 2 1/4 plus a negative 2 2/4. Well, 2 plus 2 is 4, and 1/4 plus 2/4 is 3/4. So this is a negative 4 3/4. You just have to practice working with these fractions to get this to make sense to you. So the x-coordinate is negative 3. The y-coordinate is a negative 4 3/4. And remember that this point is on the graph of this equation, a line that is the graph of this equation. Remember that these two coordinates are a solution to this equation. They will make this equation true. So over here, 2 is equal to 3/4 x minus 2 1/2. So it's a little bit tougher because now I have x over here. I have to do more than just calculate. I have to do a little bit of algebra. So what I did first is I added the additive inverse. So this is plus a negative 2 1/2. So plus a negative 2 1/2. So I wanted to rewrite this as the inverse operation, and the additive inverse of a positive 2 1/2 is a negative 2 1/2. So now I can add a positive 2 1/2 to get rid of this, and I add the positive 2 1/2 to the left side. It's right here. So 2 plus a positive 2 1/2 now equals 3/4 x. So that's 3/4 x right here. So I've gotten rid of this negative 2 1/2 on the right side, and I moved it over to the left side as a positive 2 1/2. So now I have 2 plus 2 1/2 is 4 1/2 equals 3/4 times x. All right, so 4 1/2. I'm going to rewrite that as 9/2. 2 times 4 is 8, plus 1 more is 9/2 right here. And how do I get rid of the 3/4? Well, you use the inverse operation you multiply by the multiplicative inverse. So the multiplicative inverse of 3/4 is 4/3, and that's going to make this one. That's also known as the reciprocal. So 4/3 times 3/4 makes this x. And on this side, you also have to multiply this side by that same 4/3. So now we have 4/3 times 9/2. So this stuff is factoring here. So I'm going to rewrite 4 as 2 times 2 because I have a 2 here. So if I have a 2 in this numerator and a 2 in this denominator, I can cancel them out. And so I'm left with that 2. That's why I'm circling this in red, because that's what I'm left with, the factor I'm left with. 9 you can rewrite as 3 times 3. I have a 3 in this denominator. Now I have a 3 in this numerator. Those two 3's cancel out, and I'm left with this 3. So I'm going to circle that because that's the factor I'm left with, so I don't miss it. I don't get confused. And so 2 times 3 is 6. And so you're left with x equals 6. So when x is 6, y is 2, or better, when y is 2, x is 6. So these are the 2 points. This is also a point on the graph of this equation, which is a line. And also these 2 coordinates, this x-coordinate and this y-coordinate, are solutions to this equation. They make this equation true. Now I gave you this graph in the PDF so you can graph it on your own. I would graph the 2 points first. When x was negative 3, y was a negative 4 3/4. So you have to be careful on this. So x is negative 3, y is a negative 4 3/4. So that point's right here. When x is 6, y is a positive 2. This point right here. And notice where it crosses the y-axis. It's right here at a negative 2 1/2. And that's this 2 1/2 up here, but it's the additive inverse of this 2 1/2, or a negative 2 1/2. So we'll look at that in just a moment. All right, so here's the negative 2 1/2. So what I did is I changed the subtraction to addition. That's the inverse operation. I'm changing the positive 2 1/2 to this additive inverse, which is a negative 2 1/2. So now I can clearly see that the y-intercept is a negative 2.5. So that points right here, and the slope is 3/4. Well, that means every 4 units in the x direction is a positive 3 units in the y direction, or going backwards, 4 units in the negative direction, and negative 3 units in the y direction. So that change in, let's do the change in y first. That change in y is a negative 3 units. So that's the numerator, negative 3. And the change in x to go from this point to this point right here is negative 4. So it's a negative 3, the change in y. To go from this point to here, you're going down 3 units. That is over the change in x, which is negative 4. So you're going over 4 units along the x-axis. So it's negative 3 over negative 4, which is a positive 3/4. So you can pull out the negative 1, pull out the negative 1. Those two negative 1s cancel. You're left with a positive 3/4, which is one way of looking at that. So the slope checks, the y-intercept checks, everything seems good. This is equation E. This one has a decimal value in it, or decimal fraction. It makes it a little bit different. Not tougher, but just different. And I actually am going to use that decimal value on the left side, but I'm also going to change that decimal value to 3/2 on the right side. So 1 5/10 is the same as 3/2. 3/2 is 1 1/2. 1 5/10 is 1 1/2. So they are the same. So let's work down the left side first. So x is negative 3. So negative 3 times 1 5/10. Well, 3 times 1 5/10 is 4 5/10. 3 times 15 is 45. 3 times 1 5/10 is 4 5/10. But you're looking at the opposite of that. So it's a negative 4 5/10 plus 11. Well, if you add a negative 4 5/10 to 11, that's the same as subtracting 4 5/10 from 11. So 11 minus 4 5/10 is 6 5/10. It's positive because the 11 is larger. You have more positives than negatives. So the x-coordinate is negative 3. The y-coordinate is 6 1/2 or 6 5/10. And so remember, once again, that this point is on the graph of this equation, the line that's formed from graphing this equation. And also this x-coordinate and y-coordinate is the solution to this equation. We'll make it true. On the right side, when y is 2, 1 5/10 x plus 11. So I want to get everything, I want to get this x by itself. So I'm going to move this 11 over to the left side by adding its additive inverse. Additive inverse of a positive 11 is negative 11. That makes this 0. But also you have to add it to the left side. So that's plus, you're adding a negative 11 to the left side. So negative 11 plus 2 is negative 9. So now we have 1 1/2 x is equal to negative 9. So this is why I want to change this to its equivalent fraction, which is 3/2, because I'm going to multiply this now by the reciprocal of 3/2. So now this is going in the other direction when we used to work with proportional relationships. So to solve for x, if you're given y, to solve for x, you have to multiply by the reciprocal of the constant of proportionality, which is 2/3. That 2/3 times 3/2, that makes this 1. So now you're left with x equals, and so it's a negative 9 times 2/3. Well, negative 9 times 2/3, so write the 9 as factors of 3, 3 times 3, because I have this 3 here. So I know that 9 is a multiple of 3. So negative 3 times 3. So I can factor out those 3's. 3 divided by 3 is 1. So you're left with a negative 3 times 2. So what's the opposite of 3 times 2? The opposite of a positive 6 is a negative 6. So x equals negative 6. So the x-coordinate is negative 6. The y-coordinate is 2. And once again, this point is on the graph of this equation. It forms a line. This point's on that line. And also the x-coordinate and the y-coordinate is a solution to this equation. It will make this equation true. So here's a blank graph for you. So practice graphing this on your own. Place the 2 points that you figured out. So when y is 2, x is -6. So this is -6, 2. When x is -3, y is a positive 6.5. So -3, a positive 6.5. So up here we can see that the y-intercept is 11. So 11, 0, 11, this point right here is going to be on this line, and the slope is 1 5/10, or you can look at it as 3/2. So here's 0, 11, so that point is on this line. So 0, 11, this is the slope, this is the y-intercept. And so I did this 2 ways. One is using 3/2 as the slope, because 1 5/10 is the same as 3/2, and a -3 over a -2 is the same as a slope of 3/2. So I'm going to go -2 units along the x-axis, so this -2 here, and a -3 units along the y-axis, this -3 here. So it's the change in y, -3, over the change in x, -2. That's the same as 3/2, and that equals 1 5/10. On the other hand, I can use a -1 5/10 over -1. So I'm going to go -1 along the x-axis. That's this -1 here, and a -1 5/10 along the y-axis. That's this -1 5/10 here. Once again, it's the change in y, how far you're moving along the y-axis, -1 5/10, over the change in x, how far are you moving along the x-axis, -1 unit. So -1 5/10 divided by -1 is equal to a positive 1 5/10. So that all checks. All right, so what I did is I took each of these lines from all of the equations that we solved. I took each of them and I put them on the same graph. So there's 5 lines here, 1, 2, 3, 4, 5. And first of all, let's look at this equation y equals 2. For all of these equations and all of these lines, we used y equals 2 and then solve for x. That means that they all have to have a point on y equals 2. So it can be any x value, but y has to be 2. And notice there are 4 points because one of these equations shared this point, which was 3, 2. So the x-coordinate was 3, the y-coordinate was 2. And we also solved the equation using x equals -3. So this is the line for x equals -3. So y can be anything, but x has to be -3. So there are 5 points for this one because none of those points are shared by the other lines or the other equations. So 1, 2, 3, 4, 5. So this is x equals -3, and this is y equals 2. And so now here are the 5 equations. So now you can match these equations with these lines, and it's not that bad. First of all, notice that there's only one of these lines that has a negative slope, this line right here. All the other 4 lines have a positive slope. Well, which of these equations has a negative slope? And that's this equation right here. That slope is -1. So this equation is going to match this line. Only one of these lines goes through the origin. That means only one is a proportional relationship. Of these equations, which one is a proportional relationship, which has a y-intercept of 0? That's this equation right here. So it's not too bad. This equation goes with this line right here. Now we have 2 more lines that cross the y-axis. This line right here and this line right here. Well, this line crosses the y-axis at -2 1/2 right here. So which of these equations has a y-intercept of a -2 1/2? And that's this one right here. Now remember, you have to rewrite this as adding a -2 1/2. So this can be viewed as adding its additive inverse, which is a -2 1/2. So this equation matches this line right here. This line has a y-intercept of positive 5. That's this line right here. So this equation matches this line. So now we just have two left, this line and this line. So this equation here, y equals 6x plus 8, and this equation down here, y equals 1 5/10 x plus 11. So which one of these is steeper, has the larger slope? Well, this one does. So this is going to have the larger slope, which is 6 compared to 1 5/10. And if you look at this line, does it cross the y-axis? Does it look like it's going to cross the y-axis at y equals 8? So go up to 8, 5, 6, 7, 8, and look at this line here, and it does look like that's where it's going to cross, right there. On the other hand, does this line look like it's going to cross at y equals 11, this point right here? So go up to 11, and if you look at this, yeah, it does look like it's going to cross at y equals 11. So that's it. So we've matched each of these equations with each of these lines. So go through and practice doing that. Look at the slope, see if the slope makes sense. Look at the y-intercepts. Look for positive and negative slopes. Look for steeper slopes, 6 compared to 1 5/10. If you do that, if you run that through your head, just practice, excuse me, you will get better at this. This is problem number 2. You're supposed to match the graph of the linear relationship, there's 4 of them, with its story, and there are 4 stories. So if you look at the stories, there's the weight of a kitten as it increases over time. There's the distance left that you're traveling in a car, the distance that you're away from your destination. Let's say you're going home. So how many miles are you from home as you travel towards your home? There's temperature that's increasing, and there's the amount of calories that you take in as you eat some crackers. And look at each of the graphs. So this graph is starting at 0, 0. This is a proportional relationship. So if nothing's happened on the x-axis, then nothing has happened on the y-axis. So it goes through 0, 0. This one is starting above 0 and it's increasing. This one's starting above 0 and it's decreasing, so it's going down. And this one is starting below 0. So this is a negative, whatever y is negative, and it's increasing. Here is the x-intercept. It crosses the x-axis at this point. All right, so the first story is the weight of a kitten X days after birth. So does a kitten, when the kitten is born, does it have a weight? And yes, it does. It weighs a certain amount when it's born, and then that weight increases over time. So story 1 matches graph B. So y is the weight, x is the time, and we can say the time is in days. So again, it starts with the weight when it's born. There is a weight there. So it's starting above 0, and it's increasing over time. The second story is the distance left to go in a car. Say you're traveling home. Well, you have 50 miles. Let's say you're traveling 50 miles to go home. You have 50 miles left to go to get to your home. And as you travel over time, that number of miles is going to decrease. You're getting closer and closer and closer to your home. So graph D matches story 2. So as you're traveling a certain number of miles, this is decreasing. So this is a negative slope as you get closer to home. So you have fewer miles left over time. So this is going down over time. 3 matches graph C. This is the temperature of a gas that's being warmed up over time. So X is time. So as that gas warms up over time, can the temperature of the gas be below 0? Well, yes, it can. So it can have a negative degrees Celsius. So it starts out below 0, and then it warms up over time. This is where water freezes at 0 degrees Celsius, and it increases in temperature over time. So story 3 matches graph C. And finally, story 4 has to match graph A, and it makes sense. if you haven't eaten any crackers, have you consumed any calories? The answer to that is you have not. So 0 number of crackers means that there's 0 number of calories. And this is a proportional relationship. It goes through the origin, 0, 0. If you double the number of crackers, then you double the number of calories. If you have 3 times the number of crackers, then you have 3 times the number of calories. So y is the amount of calories consumed eating x number of crackers. So this is problem number 2. This is problem number 3. You're supposed to figure out whether or not these 3 points all lie on the same line. And the equation for that line is y equals 4/3 x plus 5. So when I first looked at this, I wanted to know if when I multiply 4/3 times the x coordinate, do I get a whole number as an answer? And then all I have to do is add 5. If I don't get a whole number as an answer, so in other words, if the x coordinate is not divisible by 3, then it's not going to be a solution to this equation, and it's not going to lie on this line. Because in each case, y has to end up being a whole number. So 4/3 times 6. 3 is a factor of 6. Factor out the 6 to 2 times 3, and the 3's cancel. You get 4 times 2 is 8. 4/3 of 21. Factor the 21 into 7 times 3. The 2 3's cancel. 3 divided by 3 is 1, so they cancel. 4 times 7 is 28. And 4/3 of 99. Factor the 99 into 3 times 33. The 3's cancel, and 4 times 33 is 132. So far, so good. It looks like they are going to end up being the y coordinate after you add 5. So you have to add 5 to each one of these. 8 plus 5 is 13, so there's the y coordinate is 13. 28 plus 5 is 33, so this y coordinate is 33. And 132 plus 5 is 137, and this y coordinate is 137. So yes, it is true. All 3 of these points are solutions to this equation, so therefore they all lie on the line that is a graph of this equation. So they all lie on the same line. This is problem 4. You have a linear equation, and you're asked to show that these 2 points are solutions for this equation. And then you're asked to find the x-intercept of the line that is a graph of this same equation. So when I looked at this at first, I thought about, okay, I'm going to take the x coordinate, I'm going to replace that. I'm going to plug in the for x, the x coordinate, and I'm going to figure out what the y coordinate is. And if that works, if it comes out to be, in this case, 1 5/10, then yeah, that is a solution to this equation. So if I take the x coordinate, I plug it into the equation, so here x is 1. 1/4 of 1 is 1/4, and you're going to add that 1/4 to 5/4. So 1/4 plus 5/4 equals 6/4. 6/4 simplified, meaning that you factor the 6 into 2 times 3, factor the 4 into 2 times 2. Those 2's cancel. That means 2 divided by 2 is 1. And so you're left with 3 halves. And 3 halves, in fact, is equal to 1 5/10. So yeah, these coordinates are a solution to this equation. So what about 12/4? So 1/4 of 12 is 3. So I'm going to plug 12 in for x. 1/4 of 12 is 3. And then 3 plus 5/4. Well, that's going to be a mixed number. It's not going to be a whole number. And so it's not going to be 4. Actually, it's 4 1/4. So 1/4 of 12 is 3. So I'm going to factor out the 4 here. You're left with 3. 3 plus 5/4 is the same as 3 plus 1 plus 1/4. 5/4 is 1 1/4. 3 plus 1 is 4, and you have another 4, so it's 4 1/4. So it is not 4, it's 4 1/4. So this is not a solution to the equation. And you can see from the equation that if you take 1/4 of x, whatever x is, and you take 1/4 of it, then you have to go back and add 5/4 to that. So 1/4 of 12 is 3. And then I'm going to add 5/4 to that. So the answer is going to be 4 1/4. So that's what we get right here. Now what about the x-intercept? The x-intercept, you see that x-intercept when y is 0. So if you go along the x-axis, when y is 0, it's neither going up or down in the vertical direction. It's that point that's on the x-axis as the line crosses the x-axis. That is the x-intercept. So if you make y 0 and then calculate, figure out what x is equal to, that is the x-intercept. So if you look at this, y is 0. So now you have a situation where you have 1/4 of a number plus 5/4. That has to equal 0. When you add them together, that has to equal 0. Well, what number plus 5/4 equals 0? That is the additive inverse. That is a negative 5/4. So this 1/4 x has to equal a negative 5/4 because it's a negative 5/4 plus 5/4 equals 0. So you can write this equation, 1/4 x equals a negative 5/4. Now, normally you're not going to think about it like that. I'm just trying to give you some ways to think about these problems. Usually you just do it algebraically. So if you do this algebraically, if you have 0 equals 1/4 x plus 5/4, you're going to add a negative 5/4 to this side of the equation. So this becomes 0. So you're adding the additive inverse. And you also have to add that additive inverse to the left side of the equation. So this becomes a negative 5/4 equals 1/4 x. Well, that's what we got down here. So these are the same thing. All you're doing is switching these over the equal sign, still the same equation. Now, what does x equal? Well, if you have 1/4 of something, and that equals a negative 5/4, well, the whole thing, so I'm starting with 1/4 of x. Whatever x is, I only have 1/4 of it. To get the whole thing, to get x, I need to multiply it by 4. That means whatever 1/4 x is equal to gets multiplied by 4. So 4 times a negative 5/4 is equal to, these 4's cancel out, and it is equal to a negative 5. So x equals a negative 5. So let's look at that as a drawing. So I have x, and this is telling me that 1/4 of x, whatever this is x, and 1/4 of it is a negative 5/4. So that's right here. Well, the whole thing, all of x, is equal to 4 of these negative 5/4. So it's a negative 5/4, negative 5/4, negative 5/4, negative 5/4. Well, it's 4 times a negative 5/4 is equal to a negative 20/4. And negative 20 divided by 4 is 5, but it's the opposite of that. So this is a negative 5, which is the answer that we got over here. So let's continue with this. Let's look at this a little bit more. Let's look at that x-intercept and how we can reason through that just a tiny bit more. So what we have is a slope of 1/4, and the y-intercept is 5/4. So you go up here to 5/4, and the slope is 1/4. What that means is that for every unit in the positive direction, you're going to go up 1/4 of a unit in the vertical direction. So every unit in the horizontal direction, you go up 1/4 in the vertical direction. It is the same as every unit in the negative direction along the horizontal axis. So a -1, and then you go down a negative 1/4. So a +1, positive 1/4, it's the same slope as a -1 and a negative 1/4. So let's go in the negative direction, -1 and negative 1/4. Where do you end up? You end up at 4/4. You have taken 1/4 away from this 5/4. So it's -1, negative 1/4. Well, let's do that again. -1, negative 1/4. So where are you now? You're at 3/4. So you're going down 1/4 for each unit that you move in the horizontal direction in the negative direction. Let's do that again. -1, negative 1/4. So now we're at 2/4. -1, negative 1/4. So now we're at 1/4. And a -1, negative 1/4. So now we're at the x-axis. Well, what's that point right there? That is 1, 2, 3, 4, 5. That's -5. That is the x intercept, so it makes sense. So you're just trying to make sense of what's going on when you look at the slope and the y-intercept, what's going on with these relationships. All right, so let's continue. So this is -5, 0 is the x-intercept, and the y-intercept is 0, 5, 4. So this is a line for the equation. All of these points, the coordinates of each of these points are a solution to this equation. And that makes sense. If you multiply 1/4 times -1, that's a -1/4. A -1/4 plus 5/4 is 4/4. It's right here. If you multiply 1/4 times a -2, so let's go 2 units. That's a -2/4. 5/4 plus a -2/4 is 3/4. 5 minus 2 is 3. So that's the 3/4 right here. If you go a -3 units, a -3 times 1/4 is a -3/4. 5 minus 3 is 2/4. So this is at 2/4. So it's making sense using the equation, and it's making sense just moving -1, -1/4, and so on. All right, so if you look at the y-intercept, that is 0, 5/4. The x-intercept is whatever this point is here, whatever this x-coordinate, and we know it's -5. Let's just leave it blank for a moment. And 0, this is where it crosses the x-axis. So y is 0, where it crosses the y-axis is when x is 0. So to figure out the slope, it is the number of units along the vertical side of a triangle, or the vertical change, which is from here to here, from this point to this point, you're moving 5/4. That has a length of 5/4. So 5/4 minus 0, this 5/4 minus this 0 gives you a vertical distance of 5/4. And that ratio, the vertical distance to the horizontal distance, and the horizontal distance is how you're moving, how far you're moving from 0 and -5. It's actually from -5 to 0. So 0 minus a -5, how many units is that going to be? Well, before we figure that out, and we know what it's going to be, but before we fill that in, let's think about what this ratio means, this relationship between the vertical change and the horizontal change. It's 5/4 is the vertical change over the horizontal change, which we don't know just yet. We're not going to fill that in. But what does that equal? That's the slope. That equals 1/4. Well, 5/4 divided by what number is going to equal 1/4? So 5 of anything divided by what number gives you one of those things. So we have 5/4. We're going to divide it among a bunch of groups, and each group is going to get one of those things. Well, how many groups are we going to divide that 5/4 among? The answer is 5. So it makes sense that this is 5. So it has to be a positive 5. So 0 minus a -5 is going to give you a positive answer, a positive 5. So what goes in here is a -5. 0 minus a -5 equals a positive 5. And so 5/4 divided by that 5 is equal to the slope. It gives you an answer of 1/4. These 5s cancel out, and you're left with 1/4. All right, so the x-intercept is -5, 0. The y-intercept is 0, 5/4. And figuring out the change along the vertical axis over the change along the horizontal axis gives you an answer of 1/4. That is the slope. This is problem number 5, and you're given this drawing, and you're asked to figure out what are the coordinates of point B. Point B is right here, the coordinates of point C, and the coordinates of point D, given that the length from A to B is 5 units, and the length from B to C is 10 units. And you're also given the coordinates of point A. It's -2, which is the x-coordinate, and a -5, which is the y-coordinate. All right, so we know that the length from A to B is 5 units. And so you're going to move from point A to point B, the y-coordinate is going to be the same. You're going down the same number of units. So for A, you're going over -2 and down -5. For B, you're going to the right so many units. We're going to figure out what that is in a moment. But also you're going down along the vertical axis a -5 units. So this point here is going to have the same y-coordinate. The x-coordinate is going to be a -2, and you're going to move 5 units in the horizontal direction. So it's -2 plus this 5. So it's -2 plus 5, and the y-coordinate is a -5. So the x-coordinate is a -2 plus 5. Well, 5 plus -2 is the same as 5 minus 2. That equals 3. So the coordinates for B are 3, -5. So now we're going to move up to C. And notice that the x-coordinate now is going to be the same. So this is 3 units for B. And for C, the x-coordinate is going to be 3 units. Now we just have to figure out the y-coordinate. How far is it going up from this x-axis up along the vertical, in the vertical direction to get to point C? Well, we know that this whole length is 10 units. We know that we're starting here at -5, so it's -5 plus this 10 units to get to C. Well, what's -5 plus 10? So -5 plus 10 is equal to +5. So 10 minus 5, or 10 plus a -5, is equal to +5. So the coordinates of point C are 3, 5. All right, so we have B, we have C. Now what about D? Well, one of the things that we know is that the slope of this line is 2. How do we know that? Well, the change in the vertical direction is 10 units. From this point to this point, you're going up these 10 units. And the change in the horizontal direction is 5 units. From this point to this point, you're going over 5 units. So that ratio, these 10 units to these 5 units, gives you a slope of 2. Well, if that's true, so a slope of 2. So for every unit you move in the horizontal direction, you're going to move in the vertical direction 2 units, +2. So it's +1, +2. So if we start here, we move over 1 unit. How many units do we move up? We move up 2 units because the slope is 2. So now we're at -1, -3. So -2 plus 1 is -1. And -5 plus 2 is -3. And so now we're going to move over 1 more unit. So -1 plus a +1 is 0. So now we're going to be at the y-intercept. We're going to move up 2 units. So -3 plus 2 is -1. So this point D right here now is at point 0, -1. It is the y-intercept. We know it's the y-intercept because we ended up at the y-axis right here. So we started at -2, and we added 1 unit and another 1 unit, so that equals 0. So this point is 0, -1. So the coordinates for D are 0, -1. The coordinates for B are 3, -5. And the coordinates for C are a +3, +5.